next thing. I didn't do the third one. We can do that one in class. And we'll do more examples in class. All right, let's go to this one. Analyze a given function. Remember, I just finished talking about what does that negative exponent do? It has nothing to do with negatives. So a negative exponent is going to reciprocate the term. So what you really have there is the following. You really have 3 and then x squared on the denominator. Hey, that's a rational function. So that x is going to the denominator. Now the function does not exist at x equals to 0. This is a discontinuous function. At x equals 0, there's nothing there. Let's take a look at what that looks like. Here we go. I went ahead and graphed it ahead of time. There it is. 3x to the negative 2 power. You see what I'm talking about? So this right here, at x equals 0, the graph does not exist. Now, if you go to Desmos and zoom in, you'll see the thing kind of getting closer and closer and closer, but at x equals 0 is not going to exist. So this is a different kind of rational function, and that's because of the even number term. So all you're going to say in here is that the function is discontinuous. If I ask you anything about discontinuity, you'll say if there's infinite discontinuity at x equals 0, the domain is from negative infinity all the way to 0, and then from 0 in union with 0 to infinity. Like that's where the graph exists. It exists over here, then it's going to disappear in the middle, and then it's going to reappear after the 0 and go to infinity. The range, you can see that there's nothing on the bottom, so the range is from 0 to infinity. So let's go ahead and one more time. When you graph these, remember that you get to use the graphing calculators on these things, but just so you have an idea of why this is the case. So if I ask you for the domain and range, guys, what you're going to say is the following. You're going to say the domain is from negative infinity to 0. Put a parentheses there because there's nothing at x equals 0. There is nothing. You can't have a 0 in the denominator. And then it disappears, and then there's a second part to it in union with from 0 to infinity. That's your domain. The range of this function is from 0 to infinity. As you can see, the graph will get closer and closer and closer and closer to 0. We talked about this in the other unit. So some of those concepts are going to kick back in. That's why it's good to learn it, so that when you get back to this one, it'll make perfect sense to you. If I ask you for the end behavior, guys, of that one, you're going to say the limit of f of x as x goes to negative infinity. Remember what I talked about, that you will have to analyze the graph. Whenever it levels off to a number. It's getting closer and closer to a number. X squared is too big to fit into the 3, so it goes in 0 times. This is again something that we spoke about in the last unit. As x goes to positive infinity, the function is going to 0. It's leveling off to 0. And you'll be able to answer all sorts of things. If I ask you what is the y-intercept, well, there is no y-intercept. It gets closer to the y, but it never touches it. What's the x-intercept? Well, there is no x-intercept. It gets closer to the x, but it doesn't touch it. So this is how you're going to analyze the graph. You're going to answer whatever questions we have for you. It could be about domain, could be about range, could be end behavior, y-intercept, x-intercept. We could ask you so many things about the graph. Is it continuous or discontinuous? We could still ask you questions about that. All right, look at the next one. It's also x to the negative 5 power. So if I graph that, whoops, hold on. So on that one, it's going to be actually like this. G of x is equal to 2, and then there's a 3 in the bottom, but guess what? That x to the negative 5, that negative x1 is going to flip the x to the denominator, so now it's going to look like this. So once again, x cannot be 0, so it's going to disappear at that particular place. Let's go ahead and take a look at how that one looks. Here's my graph. See? Once again, the reason the graph is going to disappear in the middle is because that negative exponent is taking that x to the denominator, which means that x cannot be 0. So the function is discontinuous at x equals 0. That's where the graph kind of disappears. The domain, negative infinity to 0 in union with 0 to infinity. And the range, the same thing. Remember, range is from the bottom up. So the range is from negative infinity to 0. Now that line looks like it touches, but it really doesn't touch. You can check the table, and we can do that in class. I was going to get super close, but it will not touch 0. So the range is from negative infinity to 0, and it disappears, and then it reappears from 0 to infinity. Again, this is the way those things are going to work. Now, there are some patterns here when it's an even term on the denominator. When you have x squared on the denominator, it looks like a little volcano. And when it's like an odd number on the bottom, when that x to the 5th is on the bottom, the denominator, it looks like kind of like a regular rational function. Take a look at this next one, negative 2x to the negative 4 power. It looks like a volcano, but the negative has flipped it over, and that's why it's like a reverse volcano there. Okay, let's go back to this one here. We're going to analyze more functions. Remember that the fractional or rational exponent, that fraction has nothing to do with fractions. It actually means that you have a square root. So let's go ahead and do this one. So this right here can be rewritten as x to the 5th power inside the square root. So that's really a radical function, but it's going to get a little weird. Let's check it out. I'm going to go ahead and graph this one here. I've already done it ahead of time. See, the normal radical function would have gone like this, but this one, because of the 5, is actually being stretched, so it stretches it out. But it's still very similar to a rational function, to the one that looks like a radical, but like a radical function, but it goes up. So the domain is bracket 0. By the way, there is a 0 value there. When we get to class, you'll see how if you put a 0 there, or let me just go to the value. If you put a 0 in here, 0 times 0 times 0 times 0 times 0 is 0, and the square root of 0 is 0. It does exist. So if I ask you for the domain on this one, you're going to say the domain is from 0 to infinity. The range, remember the range would be also the y values. The y values begin from 0 to infinity. The end behavior, well, if you look at the graph, there's only one end behavior. There's no end behavior on that side because it doesn't exist over there. So there's only one end behavior, and that's to the right, and that is going to infinity. So if I ask you for the end behavior for that one, you would only give me 1. You'd say the limit of f of x as x goes to infinity is infinity. As we're going more and more to the right, the function goes further and further up. All right, the x-intercept is 0, the y-intercept is 0, just like on the other function. And again, all you're going to do for these guys is you're going to graph them. So a, b, and c are all radical functions, and that's because that fractional exponent has nothing to do with fractions. The denominator means it's the root. So like this one right here, the letter, I put C and D. I guess I must have had a B and erased it. But anyway, okay, so this one right here that's labeled C is 6x to the 5/3 power. So x is to the 5th power inside the cube root. If we look at that one, they're going to start getting very weird here, guys. Look at how it looks. It looks like a regular cube root function. It's going to, so the same thing is going to happen. Let's look at the next one. Right here, this is a 4th root. Again, it's looking very, very weird, but this is like the x to the 3/4 power. But that one is in radical form. And I went ahead and graphed that for you guys, and look at what it is. See, it's going to be the same as the other one. So you're going to actually type in a lot of these. You're going to need a graphing calculator, or you're going to have to depend on Desmos. There are some hints I can give you in class tomorrow so you can recognize how they look if you want to learn how they're going to look without a use of a graphing calculator. But I don't mind if you use one, because I know these are very weird, non-common type functions. Okay, let's move on. So the last thing we're going to do is solve radical equations, and here's where we're going to do a little bit of the math. So we have a square root function. You can't do anything. That square root protects everything that's inside of that root. So what you need to do is get rid of it. So what you're going to do is you're going to square both sides, because the opposite of a square root is a square. When you square both sides, the square root and the square are going to cancel out. They're going to offset each other. You will now have x plus 3 quantity squared. Here's where it gets a little tricky for some of you, but FOIL method again. We got x plus 3 squared, which means you have an x plus 3 times another x plus 3. As you're seeing this course develop more and more, you're seeing how you're going to need to know how to use the FOIL method, guys. If you still don't know, multiply this out. Again, we can, I'm going to go ahead and do this fast because the video, I don't want to make it too long. But if you have issues, all I'm doing is I'm doing x plus 3 times x plus 3. I'm doing the FOIL method, and I got x squared plus 6x plus 9. All right, now it looks like something I can do. let's move the 15x and the 5 to the other side. And if I do that, I'm going to zero out here. So I'll have x squared, and then you're going to have 6x. Remember the minus 15x, minus 15x. So 6x minus 15x is going to be minus 9x. Now plus 5, so 9 plus 5 is 14. Hey, now we have a basic quadratic formula. FOIL method again, we're going to have to do it again, but this time we're going to use the FOIL method in reverse to factor. Again, because of the time limit, I'm going to go ahead and factor this for you and tell you that it's x minus 2 and x minus 7, because negative 2 times negative 7 is 14, negative 7x, negative 2x, and negative 9x. We can talk more about it in class if you have issues on the FOIL method, but it's something you should have picked up from Algebra 2, and we've been reviewing it in this class over and over again. All right, now you solve for x just like we did before in week 1. X minus 2 equals 0, therefore x equals to 2. X minus 7 equals 0, therefore x equals 7. So it looks like my answers are 2 and 7. Now, typically when we have square roots, we want to make sure that both answers are going to work, that there's no extraneous solutions. So if you substitute a 2 back in here, let me go ahead and do this. If I substitute a 2 back into the x there, I get 2 plus 3, which is a 5. And if I put a 2 in here, 15 times 2 is going to be 30. 30 minus 5 is 25, and the square root of 25 is 5. So it looks like when I test out the 2, it does work. Let's do the same thing for the 7. 7 plus 3 is 10, and then 15 times 10, if you do that right here, 15 times 7 is going to be 105, minus 5 is 100, the square root of 100 is 10. It works. So, and again, you can take your time and do that. I'm doing it fast because I don't want to make this video too long. All right, so now the answer is going to be that for A, x equals to the set containing 2 and 7. There are 2 answers for this. X is equal to 2 and 7 as well. So here's my answer. Let's do the last one over there. Again, remember, I'm going pretty fast here, but you guys can pause, slow down, rewind, take down some notes, replay the video. When we get to class, if something didn't make sense, you ask me, we go over it, and then maybe you can come back and replay the video, and then hopefully it'll make more sense. Some of you are just sponges at this and you're gonna figure this out and no problem, but not everybody is wired the same way. All right, so I'm gonna go ahead and do B. So I'm gonna do minus 3, so that's gonna be 7 minus 3 is 4. Now I have to get rid of the cube root. Just like on the square root, I can't touch that, but I can get rid of it with the opposite. The opposite of a square was a square root. The opposite of a square root is a square. The opposite of a cube root is a cube. So what you're going to do is you're going to cube both sides. If you cube both sides, on the left side, the cube root and the cube will cancel out. And in the right side, you're going to have 4 times 4 times 4. You're going to cube it. That'll be 64. Now, minus 8, this one's going to be not too bad. That's going to be, what, a 56? And then divide by 4, so that'll be 14. And it looks like we're done. You should test it out, but I can tell you that that's going to work. That should do it for today's lesson, guys. So once again, please remember you can pause, rewind, replay this video, take down some notes as needed. And again, be ready with your questions tomorrow or the next time that we meet in class. All right, guys, we'll see you all. Bye-bye.